Good evening. Today we are once again revised. This chapter is the matter pure, and there are so many words we crosses in this lesson. One is a pure substance mixtures like this. So what is a pure substance? Pure substance means we already discussed here. Pure substance means two things. One is a pure element, pure compound. So means what is saying, the substance contains only one kind of particles, only one, either a atoms or molecule of element or molecule of compound, whatever may be, only one kind of particles are present, then it is called pure substance. So what is a mixture? Mixture means when two or more components are mixed together, these components existing side by side, means they are coexisting without losing their properties. They retain their properties without chemical reaction, without any chemical change. Just they are having their own properties, but their particles are mixed side by side. Then it is called a mixture. So in mixtures, whatever the components are mixed can be separated by simple method like a filtration, boiling or evaporation and heating, so on process. Next one is heterogeneous mixtures. Heterogeneous mixtures means when two or more components are mixed together, and these mixed components remains in a separate layers, not uniformly mixing, not equally mixing. In one part of this mixture, there is one component is more. In another part of the mixture, another component is more. So different compounds are present in different layers. So therefore, it is called heterogeneous mixture. Means the components are not uniformly mixed. They are mixing, and they are not losing their properties, but they are not uniformly mixing. Then it is called heterogeneous. Homogeneous mixtures means the components are uniformly mixed together. So these components are not easily separated by filtration. So these homogeneous mixtures are the components are uniformly mixed together. So now next, solution. What is solution? Solution means a homogeneous mixing of two or more components. Homogeneous mixing of two or more components is called a solution. So therefore solution is a mixture. Suppose when you add sugar to the water, or when you add sugar, salt and water, so all these components are mixed together uniformly, then we are calling as a solution. So we can say heterogeneous solution, homogeneous solution. Solutions. Next, suspension. Suspension means one component distributed in the another component in large size particles. They are visible to our naked eyes. The particles visible to our naked eyes, and they scatter the light. When you left for some time, they settle at the bottom. So they are separated. So it's nothing but what? It is a heterogeneous mixture. So that is called suspension. Suspension means a component mixed with another component heterogeneously, and the particles of the substance are very large, comparatively large in size, visible to our naked eyes. They can scatter the light. So these particles settle down when you left the mixture aside for a few minutes. Then it is called a suspension. Now what is emulsion? Emulsion means emulsion is also heterogeneous mixture. It looks like homogeneous, but really it is heterogeneous mixture in this two liquid or more liquid components are mixed together, they are mixed heterogeneously. And these particles are not visible to the naked eyes, but they can scatter the light. Understanding? Emulsion means when two or more liquids mix together and they are mixing in heterogeneously. So therefore this emulsion also heterogeneous mixture. So in this, the particles are not visible to naked eyes. It looks like homogeneous. It can scatter the light, but it can scatter the light. So this is called emulsion. This is called emulsion. So in emulsion, light is scattering. In suspension, light is scattering. But in suspension, the particles are visible to naked eyes. In emulsion, particles are not visible. In suspension, we find it is heterogeneous, visible, observable, and in a emulsion, it looks like homogeneous. So for example, milk is a emulsion is a looks like homogeneous, but really it is not homogeneous. Next, colloidal dispersion. Colloidal dispersion means the particles are smaller in size. The colloidal substance size is 1 nanometer to 100 nanometers. 1 nanometer to 100 nanometers. It is called colloidal particles. And these particles are dispersed in the another substance. So therefore it is called dispersive. The colloidal substance here, solute is called dispersive, and solvent is called dispersion medium. So the dispersive dispersed in the dispersion medium. So these particles are also scatter the light. Colloidal particles also scatter the light. So next one, solvent. Solvent means the substance which is large in quantity. The substance is present in a large quantity and it dissolves the solute. Is called solvent. Then what is solute? A solute is a substance in a small quantity present in the solution. A substance in a small quantity present in the solution. It distributes in the solution, in the solvent. So the solute distributes in the solvent in a homogeneous manner. So it is called solute. So next, concentration of solution. What is the concentration? Concentration means the certain amount of solute present in the a given solution. Certain amount. So for example, 10 grams dissolved in 100 gram water, or you can say 100 gram water, 100 gram sugar present in the 1000 gram water. Like this, some amount of solute present in the given solution is called concentration of the solution. So this concentration of solution can be represented different ways. So we are represented like a weight percentage, weight fraction, volume percentage, volume fraction, mole percentage, mole fraction, molarity, normality, formula, like a different ways we can represent the concentration of the solution. Next one, Tyndall effect. So what is the Tyndall effect? Tyndall effect means when a light touches the colloidal particles, the light scatters. So this scattering of light on striking the particles in the solution is called Tyndall effect. So by using Tyndall effect, we can observe whether the given substance is a pure solution, is an impure solution, is a colloidal solution, or is emulsion, or is a suspension. We can identify it is a pure suppose the solution is a pure solution, homogeneous solution. We find that the light passing without any scattering. So if the light scatters, means it is a impure solution. It comes under either colloidal solution or maybe comes under the suspensions. Next one is evaporation. Evaporation means the spontaneous transformation of the liquid substance into vapors. That is called evaporation. Okay, understand, evaporation means the transformation of the spontaneously transformation of a liquid into vapors is called evaporation. Now, centrifuge. Centrifuge means the separation of the mixture from lighter particles from heavier particles is called centrifugation. Centrifuge. Centrifuge is a machine. Centrifuge is a machine which can separate the lighter particles from the heavier particles of the mixture is called centrifuge. Immiscible liquids. Immiscible means when two or more liquids mixed together, they are not homogeneously mixed. They are not homogeneously uniformly mixed. Then it is called immiscible liquids. So for example, kerosene mixed with water. What happens? First they are mixed together and after a few minutes left aside, so the kerosene forming one layer, water is forming another layer, different layer, distinctive layers. Then it is called immiscible liquids. Miscible liquids means when two or more liquids are added together, these liquids are homogeneously mixed together, then it is called miscible liquids. So for example, kerosene mixed with the petrol or petrol mixed with diesel, all these liquids are mixed homogeneously, then it is called miscible liquids. Next, chromatography. Chromatography means we are using a method to separate the pigments based on colors and size of the particles. Generally, we are using this method to separate the pigments, like a red pigment, black or green pigments. So based upon the size of the particles, so the colors, these are separated through filtration papers, that is called the chromatography. So distillation. Distillation means separation of the components of a mixture based on boiling point, where the boiling point difference is more than 25 degrees centigrade, then we can separate it. It is called distillation. So distillation is a separating process. In this, the components of the mixture have a boiling point difference more than 25 degrees. So here the distillation is based on the boiling point of the components of the mixture. That boiling point difference of the component must be more than 25 degrees, then we can say distillation. Fractional distillation means, so here this is also a separating process, is a method, physical method. In this, the components of mixture are separated based on the boiling point, where the boiling point difference is less than 25 degrees centigrade. So elements, compounds. Elements means the elements is a pure substance, compound also a pure substance. But element substance cannot be further divided into simple substances by chemical means, chemical reactions. Therefore, it is called elements. By any means, we cannot separate substance into simple substances. It contains only one kind of particle. This is called the element. Now, what is a compound? Compound is also a pure substance. The components of the compounds are not separate physical methods, but they are separated by chemical reactions. The components of the compound are separated by chemical reactions, but not by physical means. Therefore, it is called a pure compound. So, let us see this. Here you have to explain this one. There are some words are given: solution, solvent, solute, dissolve, soluble, insoluble, filter, Understood. So like these are different words are there. We already discussed what is solution. Solution means when two or more components are homogeneously mixed, it is called solution. What is solvent? The component with a large quantity and dissolves the solute is called solvent. Solute means the component which is dissolving in a solvent is called solute. So it means a small quantity of substance dissolved in a large quantity of solvent is called solute. So dissolve means distribution of this one substance into the another substance through homogeneously is called dissolve. Dissolve means a component breaks into simple particles and they distribute through the space in the another component is called the dissolve. Soluble. Soluble means the formation of homogeneous mixture. When two or more components are mixed, so they are mixed homogeneous is called soluble. Insoluble means the components are separated. After mixing, the components are separated is called insoluble. Insoluble means heterogeneously. Filtrate. Filtrate means when you filter the substance, the liquid passing through the filter paper and collect the beaker is called filtrate. Filtrate means the extract through the filtration. And residue. Residue means the substance which is left over in the filter paper is called residue. Next, saturated solution means saturated means so the maximum amount of solute dissolved in the given solvent. The maximum amount of solute dissolved in solvent at a given temperature is called saturated solution. Pure substance. Pure substance means the substance contains only one kind of particles. The substance contains only one kind of particles. Means maybe one kind of atoms is called pure element. One kind of molecules are pure compound. So pure substance are two. Pure element, pure compound. So in both the cases, only one kind of particles are present in the given substance is called pure substance. Colloids. Colloids means the particles whose size is 1 nanometer to 100 nanometers. 1 nanometer to 100 nanometers, they are called colloids. These colloids are not visible to naked eyes, but they can scatter the light. The colloidal particles are very small, not visible to naked eye. They can scatter the light and their size is 1 nanometer to 100 nanometers. Suspension. Suspension means it is a heterogeneous mixture. In this, the solute particles are large in size, visible to naked eye. They can scatter the light. They can separate through filtration is called suspension. Now let us go to this and classify this homogeneous or heterogeneous. Soda water. Soda water is a what you call homogeneous mixture. Wood. Wood is a compound. Wood is a compound, not an element. Air is a homogeneous mixture. Soil is a compound. Vinegar. Vinegar is a compound. Filtered tea. Filtered tea is a compound. So that means it is a homogeneous mixture. How would you confirm that a colorless liquid given to you is a pure water? How do you confirm that a colorless liquid given to you is a pure water? How can you put it here? So if we supply the electric charge through the water, if the water is chemically decomposed only with hydrogen and oxygen, only hydrogen and oxygen particles, then it is called pure water. So pure water is a compound. It breaks into hydrogen and oxygen in chemical reaction. So among these, which is a pure substance, you can say ice. Ice is a pure substance. Milk is not a pure substance. Iron is a pure substance. Hydrochloric acid is a pure substance. Calcium oxide, pure substance. Mercury, pure substance. Brick is not a pure substance. Wood, not a pure substance. Air. Air is also a pure substance. So like this can, because here in ice only water molecules are there, so therefore it is a pure compound. Iron, only iron atoms are present, so it is a pure element. Hydrochloric acid contains HCl molecules, pure compound. Calcium oxide molecules are pure substance. Like this you can classify it. Mercury is only mercury atoms are there, is a pure substance. Identify the solutions among the following. Soil. So soil is actually you can say is not a pure is not a mixture. It is a chemicals are there, mixtures are there. Both are combined, not only one kind. Sea water is a mixture of different compounds. Air is a mixture of different gases. Coal is an element, it is not a mixture. Soda water is a mixture of the water and carbon dioxide. Which of the following will show the Tyndall effect? We know Tyndall effect means when we supply the light rays passing through the solution, if the light ray is scattered and touching the invisible particles, then it's called Tyndall effect. How can you demonstrate Tyndall effect? In salt solution. So salt solution is a homogeneous solution, so here no Tyndall effect. Milk is a heterogeneous, it is a Tyndall effect. We can observe the Tyndall effect. So copper sulfate solution, no Tyndall effect. Starch solution, we can find the Tyndall effect. Classify the following into elements and compounds and mixtures. Sodium element, soil is a mixture, sugar solution is a mixture, silver is an element, calcium carbonate is a compound, tin is an element, silicon is an element, coal is a element, air is a mixture, soap is a compound, methane is a compound, carbon dioxide is a compound, blood is a mixture. Classify the following substance in the below given table. Here is a solution, suspension, emulsion, colloidal dispersion. See, ink. Actually, ink is a suspension. Sea water is a solution. Brass is a solution. Fog is a colloidal dispersion. Blood is emulsion. Aerosol spray, colloidal dispersion. Fruit salad is a suspension. Black coffee is a solution. Oil and water is a colloidal dispersion. Boot polish is a colloidal dispersion. Air is a solution. Nail polish is a colloidal dispersion. Starch solution is emulsion. Milk is a suspension. So like you can classify these different ways. Right. Determine the mass by mass percentage. Determine the mass by mass percentage concentration of a 100 gram of salt solution which contains 20 grams salt. So mass relation, you have to take it. Mass relation. In this relation, mass of solution, mass of salt solution is 100 gram and salt is 20 gram. Mass of salt is 20 gram. Here solution means solvent plus solute. Here solvent is water, solute is salt. Here the solution is 100 grams and now salt is 20 gram. Now you find water is how much is there? 100 minus 20 gram. That means 100 is equal to 80 plus 20. So you can find the percentage. How can you find the percentage? 20 gram dissolved in 80 gram water. If you take the 100 gram, contains how much? So what is the percentage? Percentage means amount of solute present in 100 gram solvent. 100 gram solution. 100 gram solution. So therefore, this is not necessary to compare. So we can compare like this. So in this case, 20 gram dissolved in 100 gram solution. Therefore, it is called 20%. It is known as means amount of solute dissolved in 100 gram solution is called percentage. Amount of solute means the number of grams of solute dissolved in 100 gram solution is called percent. Therefore, here in this case, 20 gram dissolved in 100 gram solution. Therefore, it is called 20%. Next one. Calculate the concentration in terms of mass by volume percentage of solution. 2.5 gram potassium chloride dissolved in 50 ml of potassium chloride solution. So, mass volume percentage, let us see. Mass of solute present in 100 ml solution is called mass volume percentage. That means here in this case, mass of potassium chloride. Potassium chloride is 2.5 gram. And volume of solution is 50 ml. So in this case, 50 ml solution contains 2.5 gram solute. 100 ml is volume. Solution contains how much? So here is the volume percentage. Is equal to mass by volume into 100 is equal to volume percent is equal to mass is how much is there? 2.5 by 50 into 100 is equal to 50 ones, 50 twos. 2.5 is equal to 5.0%. So that is the 5%. So this way you can say mass of potassium chloride 2.5 grams, volume of solution 50 ml. So 50 ml solution contains 2.5 grams. 100 ml solution contains how much? Because we have to find out the means the amount of mass solute present 100 ml is called mass volume percentage. So therefore mass volume percentage is equal to mass by volume into 100. Here mass is 2.5 ml, 50 ml into 100. So you can calculate these values. Okay. So we'll continue this next period. So the next we'll start this another chapter, atoms and molecules.